Hey, it's John here, and we are going to do merge sort in Python. So let's start by making a few sample arrays. A equals a bunch of numbers. B will be some other numbers. And I'm going to put B in order because we're going to use that later for testing our merge. So let's just do some numbers in order here. Okay, so merge sort is a divide and conquer algorithm where we're going to break our array in half and then take each of those two halves and merge them back together. So there's going to be a function for splitting our array. And there will be another function later for merging our array parts. So R1, R2, and then finally we're going to have the overall merge sort of some array. So let's deal with splitting our array first. So the first thing we do is we're going to find our index that we're going to split on. So we'll say our index equals the length of the array divided by 2. And that would actually give us a floating point value, so we're going to change that to an integer. Okay, and then once we have that value, then we're just going to take splices of the array and return each of those splices in a tuple. So we're going to return array from the first element to the index, and then we're going to return the array from that index to the end of the array. So let's test that out. We'll do print a, let's just try it on each one of those. A, B, and C. Okay. And that didn't work at all. Right, because we wanted to split them before we return it. Alright, let's try again. Okay, very good. So we have 1, 3, 4, 6, 5, 7. So that's split right in the middle. 4 and 6, 8. So we ended up, if it's an odd number, that the second array has more values. And that's fine. We actually don't care. So that works just fine. Okay, so we have that worked out. So now we need to make our merge algorithm. And so basically we're going to take our two arrays and we assume that they are already in order, they're already sorted. We're just going to make a pointer to the first element and then compare those two first elements, and then whichever one is smaller, we're going to use that and then increment that pointer for that first, for the chosen array, and then basically walk our way through each array taking the next element. from either one until we've got all the elements. Um, so let's make our index 1 is equal to 0. Our index 2 is equal to 0. And we are going to do for, let's just say, I in the range of length array 1 plus the length of array 2 we're going to do essentially if r sub 1 of its index is less than array 2 of its index, essentially an index for each of these that we're going to walk, then we're going to make, let's just make a return is going to be our return value. We're going to append array 1 of its index and then increment that. IDX1 plus 1. Otherwise, we are going to append array 2's index, IDX2. Okay, so we also need to do some boundary conditions. For example, if we've already gone all the way through index 2, then we want to, if index 2 is higher than the number of values in the array 2, then we need to choose array 1. So if IDX2, before we do that, don't forget, we want to increment IDX2. Okay, so if IDX2 is greater than equal to the length of array 2, then we know we've walked all the way past it. The other condition we need to look for is that IDX1 needs to be less than the length of array 1. Okay. So just need to make sure we don't walk off the end of each of those arrays, so that has that accounted for. I have redundant parentheses. Right. Okay. So, and it wants one more space here. So that should be the algorithm. And then when we're all done with our for loop, we're going to return our return value. So let's test that. We can, now that we have B and C, which are already sorted arrays that we can use. So let's do a print okay, what is it complaining about here? Print merge B and C. see if that worked. Okay, so we have 1, 4, 5, 6, 7, 8, 9, which you can see is correct. Maybe try a D. We'll do C and D, then have the same number of elements just to see if that works as well. And that works as well. So we probably got that right. Oh, we don't need semicolons. And we want double blank lines. Okay, so we have our split function, we have our merge function, so now we can start writing our merge sort. So, oh, we can't do a hyphen in this language. Okay, so it's a recursive function, so I'm first gonna check our base case. If the length of the array is less than 2, then we can just return the array. It's a sorted. An array that's smaller than size 2 is already sorted. Otherwise, we want to split the array. So now it's going to be in 2 pieces. Let's say pieces equals split our array. And then what we want to do is merge the 2 pieces. And we want to sort each of those pieces. So we're going to merge, sort pieces 0, and merge, sort pieces of 1. And we can return that. Another space there. Alright, let's try that out. Merge, sort. Let's do merge sort A. Let's see, it's going to return it and then we want to print it. Let's do print format. No new line into file. Sure, there's your new line. Alright, here we go. Let's see, the first print was that one. We can take that away so it's not confusing. And the second line is what it was. Run it again. 1, 3, 4, 5, 6, 7. Let's put our data down here. Okay, let's just make some test cases. So I'll do an odd number. Let's do B here. 6, 7, 8. Okay, so it worked with an even number, an odd number. It'll probably work with stuff that's already sorted. So I'm satisfied that this is correct. So that is how you write merge sort in Python.